What is going on, guys? Welcome back to another coding challenges video here on Neural 9. We're going to do Codewars challenges again, meaning unfiltered, unprepared, showing you my raw thought process, solving the problems live, and either showing you the path to success or showing you how I fail. So let us get right into it. Alright, so the rules are the same as always. I'm allowed to Google, however, of course, not the full solution. So if the task is finding the first 10 primes of a sequence, I would not be allowed to Google the solution to this exact problem, obviously, but I would be allowed to Google stuff like how to sort a list in Python, or I would be allowed to look into the documentation, or to go on Stack Overflow to figure out something about the Python language that is more general, not the full solution to the problem. I am not allowed to use ChatGPT, obviously. I'm not allowed to communicate with everyone. So basically, I'm just allowed to use my brain and to play around on my system with the local Python installation, and I'm allowed to Google, but as I said, not the full solution. So let's go ahead and warm up a little bit with a simple 6Q challenge. So we're going to go easy first, hopefully easy. Let's see what we have here. Reversing a process. 7-segment display, playing with digits. Let's look at this one maybe. What else do we have here? Replace letters, words to hex. Or numbers, whatever that is. Euler squares. Write a number. I think this means that I did it already, right? Or at least I started it. Let's see. Does it mean that I already looked at it? Not sure. But at least I don't remember having done it. So yeah, let's look at those here. Some numbers have funny properties. For example, 8, 9, 8 to the power of 1, 9 to the power of 2 equals that. Okay, this is too mathematical. We saw what happens with the mathematical solutions here under pressure while I'm recording. Doesn't turn out to be too good for me. Yeah, this looks kind of boring. What is that? Or numbers, harmonic divisor numbers, are numbers for which the harmonic mean of all their divisors, including the number itself, equals an integer. Okay, this is again too mathematical for the video. Now, I usually enjoy mathematical stuff, but not under pressure, which is when I'm recording. So if I have to deliver here a video that's entertaining and interesting, I don't like solving too complex mathematical problems here. I think we could go with this one. Yeah, it says train again. Okay, so maybe I started it. You have to believe me at this point here that I don't know the solution to this one. Maybe I've started it, but actually, I cannot really remember having solved this one. And also, I think that, well, let me go for try again. Have I ever submitted anything here? Doesn't look like that. Let's do this one for warm-up. I don't think that I've ever done this, that I've ever solved this. But I think it shouldn't be too difficult because it says basically all you have to do is you have to take the number and you have to write it down here as the individual digits based on what position they are. So you have 1 times 10, 2 times 1. And then you have, here you would have 7 times 10,000, 0 times 1,000, 3 times 100, and you would write it like that. Shouldn't be too difficult, so let's just go through it real quick here. Let's solve this in a very simple way. This is probably not the most efficient way because I'm sure you can do something with logarithm base 10 and then you can go for the individual digits, or you can divide by 10 every time. Actually, this could actually be even more reasonable because the first thing that I wanted to do is I wanted to take the number, turn it into a string, iterate through it backwards, and then just get the individual positions times 1, times 10, times 100, and so on. But I think actually you could just take... Couldn't you just take... let me think about this. I could turn this into a string to get the length, because I think, of course, you could do that with some division and logarithm base 10. But actually, I could just use a simple string function, so a typecasting, to figure out the length of this number, to then say, okay, we have 5 positions, so I'm going to say first digit times 10 to the power of 5, second digit times 10 to the power of 4, and so on. And what I would do is basically I would divide the number by 10 to the power of, in this case, 5. And then I would truncate it and then multiply it again. So I think this should work. Let me see if this makes sense. Maybe not. But I think what we have to do is we have to say, first of all, number length. And here you could use some fancy mathematical formula. I'm just going to say length of the string of the number. And then what we want to do is we want to say, okay, maybe we could use a while loop here. So maybe while, or maybe let's say final underscore string equals empty string, then while number underscore length is less than, or actually while it's greater than 0. What we want to do is we want to take the number, maybe, I think we can work with a parameter right away, right? So we don't have to store it somewhere. So maybe I can say here that I want to have the number floor division, so cut off all the decimal places, 10 to the power of whatever the number length is right now. So this is, I think I don't need brackets here, but I'm gonna put them here anyways because I don't want to mess up the calculation. Whatever we get out of here, we can take to the power of 10 to the power of number length again. And again, I don't think that I need parentheses here, but I'm going to put them here anyways. But I think doing that, if you have a number like this here, what would happen is you would divide by 10,000, or actually this is 10 to the power of, is this 10 to the power of 4, right? I'm not stupid right now. Yeah, okay, so we would actually have to go number length minus 1. And here we do need now parentheses. So, come on, like this. And here the same thing, so minus 1. Because now what we would do is we would take this number, we would floor divide it by 10,000, which would mean we get just 7. And then we would take 7 times 10,000 again, which would be 70,000. And this is what we want to put into the string. So what we actually want to do is we want to say, maybe we want to say here first equals true. Then we can say, or actually, no, we don't need that. So what we can say is final underscore string plus equals this number. And in the end, we want to have, a plus. So that should work. Does this make sense? Yeah, but the last one, we don't want to have a plus there. So actually what we want to say is if number length is not equal to 1, then we do that. Otherwise, or actually we can do it like this. We can say we always have the same string, but the plus is not always there. So if the number length isn't equal to 1, we're going to say final string plus equals space plus, and then space again. I think this makes sense because now what we would do is we would get, oh no, this doesn't make, does it make sense? No, it doesn't make sense because now what we would actually have to do is we would also have to subtract this number from this number. So we need to do an extra step here. We need to actually say here now that the number itself is the number that it was before minus the one we just wrote down. So we need to say minus equals and then basically this beautiful part here. Or actually, no, the whole thing, right? That would be it. Let me just see, how can I copy this? Doesn't work. Like this. There you go. I think this would work because now we would take the 70,000 away. And maybe if I return this now, return final underscore string. Let's see what we get here. Sends a request. Sends a request quite long. Okay, execution timed out. What am I? Oh, of course it's timed out because I would have to compute the number length after changing this in the end. Like this, because otherwise I just end up in an endless loop. Now we have a problem here. While number length cannot access local variable number length. Oh, yeah, because I deleted it from here. Okay, there you go. Test. Now it runs for quite some time. This shouldn't be too computationally intensive. I think we have a problem now again. Because what are we doing now? We're getting the length of the string. Number length. Oh, no. Actually, this should not be the problem because the number... Am I stupid now? I mean, what happens when I run this here? So let me copy this and run this locally. If I say number form.py here. If I paste this here, okay, this is a little bit too large. Let's say I want to print here with each iteration the number. Oh, I need to call the function, of course. Okay, I get 0. Need to terminate it quickly so that I can see the first couple of lines. Or I could just say, I mean, why does it keep going when it's 0? If number length... Oh. The problem is I wanted to go into it. Okay, maybe I just have to say here, and number is not 0. Now we have a problem. So, yeah, of course this doesn't work. I'm stupid because this should be just the string version of that. There you go. Now we passed all the tests. Now, I think this is not a bad solution because it's mathematical for the most part. I mean, of course, we have to construct a string. That's obvious. But I think this line here with the length could be replaced by something more intelligent. But other than that, I think it's a decent solution. There's probably a much better solution. So let's try an attempt. Let's see if everything's covered. No, it's not. Because if I only have one number, this fails. Of course it does, because we have the zeros, so nothing is appended. But I think that's quite easy to solve, because all I have to do is I would have to say strip away all the spaces, strip away all the pluses from the side, and then strip away the spaces again. I think this should work. There you go. I mean, this is really ugly here. Probably there's a better logic, but I want to solve a more difficult problem here. So let's just submit this and let's see what the best or the shortest solution is here. Oh, this one looks beautiful. What do we have here? List string number. What does he do? He iterates over the numbers, enumerates the numbers, iterates over them. If x is not equal to 0, what he does is he says, Oh, he uses this as the joining as the joining character, or as the joining string. And he basically, oh, this is intelligent. He produces as many zeros as the length minus the current position when you iterate forwards minus 1, and he does as many zeros, he adds as many zeros to the respective digit. This is a smart solution. I like this one. This is GigaChat. Okay, nice. There you go. So let's move on with something more difficult now. Let's go for 5Q, and let's this time, unlike last time, not do something too mathematical, because again, on camera, this is just not a good idea. So let's see what we have here. Last digit of a large number. Soundex. I'm always looking at the title and the categories. This is the most important thing. And when I see mathematics, most of the time when I'm recording, I'm not doing it. Which X for that sum? This sounds interesting though, even though it's mathematics. Let's see what it says. Consider the sequence UNX equals X plus 2X squared plus 3X cubed. No, this is actually too much for now. Define a function that takes in two non-negative integers, a and b, and returns the last decimal digit of a to the power of b. This requires probably some knowledge of some rule that is saying that when a certain thing is given, you have some pattern that you can look for, and then you know what the last digit is. I don't think that they want you to just compute the result and get the last digit. So what do we have here? Everything looks kind of algorithmic and mathematical. I mean, makes sense. This is a coding challenge, so what else should it be? Closest and smallest. Fundamentals sorting. Let's see. A string strng of n positive numbers, n equals 0, or n equals n is larger or equal to 2, so it can't be 1, and it can't be obviously -1, or a negative number in general. Let us call weight of a number, let us call the weight of a number probably, the sum of its digits. So yeah, I think there's a term for this. I know what it's in German, I don't know what it's in English, but basically when you compute the sum of the digits, there's a term for it actually. I don't think it's just sum of digits in English, is it? Let me know in the comments. For example, 99 will have weight 18. 100 will have weight 1. Okay, understood. Two numbers are close if the difference of the weights is small. Task: for each number in strng, calculate its weight. What is it again? It's a string of n positive numbers. Okay. So what do? We find two numbers of strng that have the smallest difference of weights, and with the smallest weights and with the smallest indices in strng. So the output is an array, which says what exactly? I didn't understand. Now, those are three unrelated things, right? No, for each number in strng, oh no, this is, okay. For each number, calculate the weight, and then find two numbers that have the smallest difference, so that are the closest, then two numbers, I guess, with the smallest weights, or is this somehow related to the first point? I'm not sure. So what does the output say? Number weight, index of the string of the corresponding number, original corresponding number in string. So here we have examples. The weights are okay. Closest should return 2 and 4. Okay. This looks kind of tedious. I think I want to do something else here. I don't think it's particularly difficult, but I think when you have to invest a lot of time to understand what they even want from you, it isn't much fun. I like solving difficult problems when I understand what they actually want me to solve, without having to think too much about what they want from me in the first place. Find the smallest. This sounds super trivial, but let's see. You have a positive number n consisting of digits. You can do at most one operation. Choosing the index of a digit in the number, remove this digit at that index and insert it back to another or at the same place in the number what? Return an array or tuple or a string depending on the language. Smallest number you got. Okay, this is again. I don't like this task. Buddy pairs. This is all mathematical stuff. Longest common subsequence. This sounds interesting. What is that? Write a function called LCS that accepts two sequences and returns the longest subsequence common to the passed in sequences. Okay, this is easy to understand. This is a task that I like. This is a task description that I like, even if the problem is complex, even if it's not trivial. It's very easy to understand what they want from you. So you have some collection, in this case a string, and what you have to do is you just have to find the largest common sequence. Super simple from the task understanding, from a task description. So here you would have ABC, here you would have ACF. Now, why is ACF a true result? Because probably it comes in the right order. So it doesn't have to be exactly present in the sequence, but they have to occur in the correct order. Which makes sense. So you can always, I guess, focus on the smaller one because you don't have to... I mean, the smaller one has to be... Or is this correct? I'm not sure. We're going to try this one. This sounds interesting. Both arguments will be strings. Return value must be a string. Return an empty string if there exists no common subsequence. Both arguments will have one or more characters in JavaScript. Okay. All tests will only have a single longest common subsequence. Don't worry about cases such as 1, 2, 3, 4, 3, 4, 1, 2. Yeah, okay, because you would have 3, 4, and we would have 1, 2. Okay. Yeah, sure. Okay, Haskell, OCaml. Okay, we're going to do this one. But it doesn't seem to be very trivial because let's think about this. What do we have to do here? Now, does it make sense to always start with the smallest one or not? I think so, because, I mean, you have to find the sequences that occur in the smaller one, and then you have to look for them in the bigger one. Now, the brute force solution here, again, would be to just, or the greedy solution, or maybe not the greedy solution, the exhaustive search here would be to just take the smaller one, see all the sequences that occur in there, and then sort them by length and go through all of them, from the longest to the shortest, to see if they also occur in the longer one, or in the other one. So I guess I'm just going to start to model a very naive approach here. So I'm going to just say if length of x is less than length of y. Maybe let's activate the Vim bindings here again. Go full screen and zoom into this. So if x is shorter than y, what we're going to do is we're going to just say that we're going to focus on x. Otherwise, so I'm going to add a pass here. Otherwise, we're going to... can we swap them? Can I swap the parameters? Can I just say y equals x and then I would have the shorter one be in x again? I mean, actually, I would have to say xy equals yx. But would this work? I think so. Let's do it like that. So or maybe we could even just say if, maybe if not, and then we can do just this. And then we can just assume that x is now always shorter than y or equal or of equal length. I think that makes sense. So what we want to do now is we want to find the sequences that they could have in common. Now, should we start with an intelligent approach right away, or should we just go with the brute force result? Let's think about this. How would you find a sequence? I mean, those are pretty simple examples. Let's maybe come up with our own example. Let's say, for example, I know that x is this. Or can we have duplicates? Can we have the same value multiple times? Yeah, we can. Okay. So let's say this is my x, and then let's say my y is something like this. Now, I just typed something in. There's no reasoning behind this. How would I find common sequences here? Now, of course, I could just go for the first character in x and try to see where it occurs in y. So I could go A, okay, A occurs here. And now I could go for every other character after y, after A, and see if it occurs in y as well after A. So if I go for S, I would have S here. So I would have AS would already be a sequence. Now, after S, I only have A, and I also have an A here. So ASA would already be one. Now, what else do we have? So maybe I don't go for S, maybe I go for B, AB. Now I don't have a B in here, so we can just ignore them. Maybe this is a first way to start this. Does it make sense to remove all the characters that don't occur in both lists to simplify the problem? Because if a character does not occur in both lists, it will never be part of the common sequence. So we can just remove it, right? Am I stupid for thinking this? I don't know. I think actually this makes sense. So we could say, how can we do that? We can say, let's just say letters to remove from X are letter for letter in Y if letter not in X. And then we can do the same thing for Y with X. And actually, we could even remove them before. So I could say X equals X, replace, or maybe 4 letter in letters to remove from X. X dot replace this particular letter with nothing. And then I would copy this and I would do the same thing down here with Y. And if I take this now and I run this locally, I think, actually I need to copy this with my mouse in Codewars. Let's use the same Python file here. So we have this LCS now, and if I go ahead and I print X and I print Y, and now I say LCS of, let's actually take the 2 strings that we have here. I mean, we don't have to take exactly the 2, but let's actually just do it. ASBHASFD SDA GKHJGSA. So if I just run this now, we removed, no, we didn't remove the B. Okay. I think we need to say X equals, right? And Y equals. This is my guess now. No, still doesn't work. Why doesn't it work? Can we actually change something? I mean, does it even... If I print a letter here, does it even do anything? Yeah, okay, it finds the letters that don't occur in both lists. So this is good, but it doesn't change anything about them, right? So it keeps them in there. So maybe replace is not the proper way to go. But why not actually? I mean, isn't it the case that when I have a string, so if I open just Python 3, if I have something here and I say replace, and I say replace S, for example, by K, this returns a string where S is replaced by K. And if I say replace it by nothing, it should eliminate it, right? So why doesn't it work? Why doesn't it work here? In my case, is it because we're working with the parameters? I'm not sure. Because it does work. It does actually print that the letters should be removed. But the replacement doesn't happen. Maybe it's actually because of this. I'm not sure. Let's just try before I think about it too much. Let's say x copy equals x. And y copy equals y. And then actually we can go here and we can say substitute x for x underscore copy. And then substitute y for y copy. And then print x copy, y copy. Actually, I don't think that this is the solution, but I would like to try. Let's see. Okay. I think I messed up something. Why is x copy copy now a thing? Okay, substitute x underscore copy copy for x underscore copy. There you go. Okay. No, it still doesn't work. Okay, why doesn't it work? Am I stupid now? I think I'm stupid now because you probably see something that I don't see. I mean, I entered two strings. B should not be an X anymore because B is something. I mean, all these letters should be replaced, right? I mean, when I print letters to remove from X copy, this should actually give me characters. And I do have those characters, but for some reason, it doesn't show that. I have no idea why. And it's probably something very stupid. So let me just check this here again in the idle. Or actually, it's not the idle, in the Python shell. I have some string x. X is ASBH ASF D. And now I say x equals x dot replace B with nothing. What is x? Okay, x doesn't have B in it anymore. So what is the issue? Let's just get rid of almost everything here. Let's keep it down to the essentials. Letters to remove from x copy. Or in this case from, let's turn it back. Let's actually copy this code again. Okay, so we remove this. Let's also just focus on x for now. Let's also forget about this here. Now, let's say I have this collection. Letters to remove from x. Oh, I'm a complete idiot. Okay. I hope you guys don't lose respect for me after watching these Codewars videos. I would not be pissed, but yeah. Of course, the problem is that we're looking for characters that are, let me just copy paste again. What we're doing is we're collecting all the characters that occur in Y and not in X. They're not in X, and I'm trying to replace them in X. So actually, we need to swap this. Damn. Programming can be hard sometimes. Python 3 number form. Okay, now nothing is happening. I think I'm not printing, right? Print X. Print Y. There you go. That's what we want to have. Okay, so now we simplified the problem massively because now we have a lot of characters removed that just cannot be there. Now, how can we simplify this further? If I have this, how can I simplify this further? Now, I would say in general, if it's not the case here, I think, but in general, if you have a string where one character occurs more often in one string than in the other one, you can remove the last. Let's say you have the string or some character occurs n1 times in the first one and n2 times in the second one. Now you take the difference of that and you can remove that difference amount of characters from the string where it occurs more often. This was a very complicated way of explaining it. But what I'm saying is essentially if you have X being ABC, AAA, BC, and then I have Y being ABC, ABC, A occurs 2 times here, it occurs 4 times here, so I can remove 4 minus 2, the last 2 instances of A. Now in this case it would make them the same, but in general you can do that, I think. Now what I'm thinking about is solving this in some sort of recursive way where I can say, okay, remove or simplify the problem until X equals Y. I think, and make sure that you don't miss anything. So maybe we should use a different example here. Maybe something where we have one more H here and maybe some stuff here like this. So in this case, we have the problem, or not the problem, but we can see that we have one H here, 2 H's here. So we could actually remove this H from here. But the tricky part is, I think, how do you figure out if, no, this doesn't make sense. I mean, you could simplify this a little bit by doing this thing. So you can say for, actually, they should now have the same characters, right? So actually, if I say character set equals set of X, what is that? Let me just drink a little bit of water here. But if I do that, shouldn't I get all the characters that are still relevant? Yeah, this is what happens. Okay, so all these characters that are still relevant, I want to know where they occur less often. And I want to remove all the additional instances in the string that they occur more often in. That's the idea. So I could say actually, for character in character set, I would say X occurrences equals X count character. And then I could do the same thing for Y. And then I could say if X occurrences is less than Y occurrences. By the way, let me just turn on the auto completion here in my NeoVim. So if I have X occurrences is less than Y occurrences, what I would do is I would say x, no, y, we have to remove them in y. I'm going to do this here in a second. Then we also have the y occurrences being less than the x occurrences. Pass. And in the end, if, or actually we don't need to do anything otherwise. So now what I want to know is how do I remove last two occurrences of character in string Python. Okay, this is actually a different thing. This is also not what I'm looking for. Is there a Python function called rfind or something? I think there is, right? Mm-hmm. Python rfind delete. Okay, so I think rfind could work. Because let me just see here. If I open up a Python shell. If I have some a's in here. And if I say rfind, or let me maybe store this in x here. If I say x.rfind a, I should get the last position where a occurs, right? So if I say x dot, do we have a pop function or something like this? No, okay. String pop item. Okay, you can do it like this. Now, not necessarily for the central one, but for the index that we're targeting. So we could say actually they want to have x up until this position. So up until 13 in this case, plus x from 14 onwards, right? No. Or is it right? F. No, I removed. What did I do now? Oh, plus 14 is, of course, 14 until the end, of course. Yeah, okay, this works. So we can basically say, I think I'm solving this in a way too complicated way, but let's see. So I can actually say here, now I just copied this here. This is going to be some occurrence. What we want to do first of all is we want to say for I in range y occurrence or y occurrences minus x occurrences, remove all these occurrences. We're going to do this a couple of times. We're going to say occurrence is x.rfind this character, and then we basically say x is that. We do that many times, and we can basically do the same thing down here, but we swap x and y. There you go. Okay, I think this should work. What's the problem here now? For some reason in NeoVim I cannot see the error messages, but we're going to see when I try to run this. Occurrence is not defined. Yeah. Now it is. Isn't it? Okay, now it seems to work. And I need to print again. X and Y. Why does it happen so many times? Because I'm doing it inside of the for loop. Now let's see, does this work? We have H, no, the second H here does exist. Why doesn't it work? So what's the logic here again? We have the character H as part of the set. So we iterate over the set. We say, okay, how many times does H occur in X? How many times does it occur in Y? We're going to see it occurs one more time in one of them. And it's either going to be this or that. Let's see. Print character when this triggers. I just want to know. H. Okay, triggers for H. Which one triggers for H? Is it the correct one? Okay, it's this one. H occurs more often in the shorter one. Which one is the short one to beginning? In the beginning? This one. Okay. This is correct. Now, why doesn't it work? For I in range, what do we get here? Probably 1, right? So let's see if this happens here. We get into this. Now what is the occurrence? 3. Does this make sense? Doesn't make a lot of sense, does it? Because it's still there. Am I removing something else? Let me maybe see. Print X, print Y. It's actually not removing anything. But also 3 shouldn't be... Is 3 actually correct? I'm not sure. Oh, I think I'm doing the same stupid thing as before. I think if it occurs more often in Y, I need to remove it in Y, obviously. So this is X here. That should hopefully work. Still doesn't work. What's the idea here? We have more H's in the Y string. We iterate over the occurrences, so over the one occurrence here, and we just find the rightmost H in Y. We note this occurrence, we print it, and then we say Y is everything up until this occurrence, plus everything after the occurrence. Oh, this is the problem. This is what I did automatically. There you go, now it works. Okay, let's say this is the simple form now, so to not waste too much time here with this example, I'm just going to now go ahead and say, from this simplified version, and we could probably simplify it further, we are just going to say now that we want to get the different sequences. And actually want to say, can we find... We're going to go and we're going to say here, I mean, at this point, they should be the same size, right? They will always be of the same length. This is correct. So whatever I type here, at the end of the day, now I'm not printing again, but at the end of this function, they should have equal length, right? Or am I mistaken? No, they always have equal length. Okay, this is good. So this will keep it simple. And now what I can do is I can say, what is the Python collection? Python collections, and then it was something like, what was it? It wasn't permutation, it was combinations or something. So, combination. Yeah, AB No, actually not, because it has to be, or actually it is. It is always in the same, in the correct order, right? So you would never have something like DB, right? So combination seems like the function that I'm actually interested in here. So from itertools, import combinations. That's it. And we're going to say now, for I in range length of x, because length of y, length of x should be the same. We're going to go up until the max length, so down to 1 essentially, and we want to start here with, I should start with 0, right? So if I print I 0, just want to make sure. Yes, no, yes, it is. And because of that, we can just go ahead and say, let's just print this to see what we get here. Combinations of x and I think I need a number. So let's actually say of size length x minus I. Missing required arguments are. Didn't I pass a second argument? Oh, not to the correct function. Can I turn this into a list? Okay, so this is of size length. This is one less than that. Okay, so I think that all we can do now is we can say xcomps, then ycomps. This would just be too much to do it on the raw input, but maybe in the simplified version it will work better. And now what we want to do is want to say for comp in xcomp if comp in ycomp, or actually xcomps, if this comp is also in ycomps, we want to print this combination. And then we want to actually break out of the loop. So the problem is, can you break out of 2 loops? I don't think so, right? If I break, I'm just breaking out of this loop. Maybe we can say found equals false, and then we can say if found break. Let's see if that works. Okay, it doesn't work. At least it doesn't recognize the combinations. Oh, it does, because it prints them, obviously. So actually, it should break here. And we should set actually found to true. And we should break. Then we should get just one result, right? There you go, ASHA. Let's see if this works, because that could be very promising. Because the result, what should the result be? A string, right? So in the end, or actually, we don't need all of this stuff. We can just return at this point, right? We don't need all of this stuff. So we can just go down here and return join comp. So let's print the output of this function here. There you go. I think even though this might not be the most elegant solution, it should work. It's very difficult to come up with the most elegant solution when you're recording, because you don't want to be boring, right? I don't want to be just sitting there thinking all the time, as I would be doing it when I would do it on my own. I want to have something to talk about, and I don't want to sit there for 30 minutes thinking and not saying anything. So I have to program in a different way. So let's just copy this into the clipboard. Let's go now to... this is the wrong one. Where was I? This was it, right? And of course we don't need that. But now I think this could work. Okay, some of them passed. None should equal empty string. So if we don't return anything, we just have to return an empty string. I guess that's where we're messing up. Also, not test should equal not test. Or why doesn't this work? So what is the input? Yeah, okay, so why doesn't this work? Oh, I see, because I'm... Okay, but maybe then I could just... remove this, right? I mean, I don't know if then it's going to be too difficult, but... Why didn't that work? Oh, of course, because we now don't have... No, this is a problem now, because we're removing, actually, if we have... We don't have to necessarily remove the last one, right? This is now difficult, because, of course, here we have another test. So we have E, and we have E, but here we only have one E. So in our algorithm here, in my solution here, we're removing this E, which is incorrect. And this is stupid. Now, the only thing is, why doesn't it find it? Yeah, because they're not the same length if I do it like that. Now, what I could do, and this is, then all of this would be a waste of time, of course, but what I could do is I could just do this. And I could do the same thing with Y. Now, this might not be the most beautiful solution, but it should probably work. I think so. Maybe. Let's see. Okay, now we have still unaccepted. R must be non-negative. Oh, yeah. Because... Okay, this makes things more complicated, but I don't think that my initial solution was too bad. I just need to take into account that maybe I cannot just return always... I cannot just delete always the right one. But how do I do this then? How do I know which one to... It seems like a problem. I mean, let's just try the last solution that I had. The problem here is that I don't know which one for I in range length X. I mean, actually, do I even need that? I can just... Can I not do it like that? Not sure. No, okay. This is a tricky one. So let me think about this again. The problem is here, what was it? Another test, and then we had not a test or something. The problem with this one is, yeah, we missed the E. This is not good. Let me just check something on my phone real quick. Okay. Yeah, so how do we solve this? If I have one more E here, basically I have to dismiss all the solutions. No, the thing is, the problem is that I'm assuming here for my solution, and I don't know if I have to do it in a completely different way, but for this part of the final iteration here, I'm assuming that length of X and length of Y is the same. Which only works because I do all of this here, because if I don't do all of this here, they're not of the same length, obviously. But, yeah, this is... Okay, let's comment this out, and let's say I don't do all of this. So what we have is we have... we only have the same letters, but they can occur multiple times in one string and only one time in the other string, or they can occur a different number of times. If that is the case, the two strings don't have to be of the same length. So I can iterate through all of x, and I can basically get all the combinations. And then, actually, can I do it like this? Where I say xy, xy, xy. And then for combination, in x combinations, if it's in y combinations, return this. And then I can do the same thing for y, for x. Okay, doesn't work at all. Why is that though? I mean, sure, because they're not... Are they sorted by length at this point? No, the problem is that maybe... Okay, this shouldn't be too difficult. Result equals none. Then I would say result equals that. Then I would say if length of result is less than length of this, then return this. Otherwise, return result. I don't know if this makes sense. Where did I miss? Oh no. Okay, it doesn't work at all. Doesn't work at all. So I have all these combinations, right? So if I comment all this out, I have all of these combinations. What do they look like? So if I have print xcomps, ycomps, oh, of course. Okay, makes sense. So we would have to say x combinations is an empty list, y combinations is an empty list, and to each of those we add now what we have here. So we would append to this list, or to those lists, we would append lists. So now we should have all the combinations. Okay. And now this should probably work, shouldn't it? None. Why none? Because we don't have y combinations? Or because we already have a result here? Still none. Why does it return none? Oh, because result is none. Because it doesn't find a combination here. This doesn't make a lot of sense though. Why doesn't it find a combination? Let me just again check a message. When I'm recording that long, I have to do some other stuff as well. This is gonna be a long video, I think. So what's the issue here? I'm iterating. I'm collecting all the combinations. Are those correct? What do I have here? I have the full word. I have... Yeah, they're all in the correct order. Oh, the thing is... Okay, I see the thing. I see the problem, I think. It's not append, but plus equals, because we can add the lists. Because in this way here, I add a list into a list. So we're not iterating actually over the combinations. There you go, not test. Okay, so now this works. Let's copy all of this into the clipboard. actually like this. Now this is not going to work immediately because we're going to fail a couple of those empty ones, but all the rest works. So what we have to do here is remove all of this here. And we just say if result is not none, else empty string, then it should pass all the tests. There you go. And I think, I mean, those are all optimizations, but I think probably for this, maybe I thought of it as a too complex problem. Maybe we can just remove all of this here and we can just run this directly. I'm not sure, but you don't actually need to, yeah, I mean, okay. It's less efficient because you have to compute all the combinations, but it also works like this. But okay, when we spend so much time on this, maybe we can simplify this. So what do we have here? We have all the combinations. Of all these combinations that we generate. But actually, maybe what we could do is we could say, maybe we don't have to generate all of the combinations if we can check first. You know what I mean? So we could say, actually what we could do is we can say, okay, if, let's say range num equals length x, if length x is less than length y, else length y. And then we could just say range number. We could do this. We don't have to print anything. And we can then just look through this thing here, and it should take less time, I think. Result equals none. Oh, yeah, none. Does this work? No. Why not? I mean, what are we doing? We're generating the combinations. We're setting the result to none. And we're saying now, for combination x, if this combination is in y as well, of the same length. Oh, no, not of the same length. This is y. Range number. That is y. Now this should work, right? There you go. And I think it was faster than the previous solution, but I'm not sure. Is this all? Can we just keep it like this? Actually, now, can I not just say immediately return this? And if it doesn't return, I do this. And I return this. And if none of those happen, I can just return this. No. Okay, no, here I would just return then an empty string. There you go. Okay, 82 seconds instead of the 82 milliseconds instead of the 170 milliseconds that we just had. So way more efficient. Can we somehow optimize this even further? I mean, we could just say here min len x len y to make it more beautiful. And here we could say length just to have more beautiful code. And actually, we don't even need that. Can we not just do it like this? No. But only because we have range number here. Yeah, works. 17.64 milliseconds. Okay, this is now way better, I think. This is way better. Yeah, I'm going to submit that. There you go. We solved this. Took some time, but now we have some decent solution. I think it would probably be better if we simplify the problem a little bit. But actually, my solution was not too bad because we don't have, I mean, what is this? Set? Yeah, but he also goes through all the combinations, right? I think so. Yeah, but solutions are not extremely short, so I actually don't feel too bad about my solution. I think we did quite well. All right. So that's it for today's video. I hope you enjoyed it and hope you learned something. If so, let me know by hitting a like button and leaving a comment in the comment section down below. And of course, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you much for watching. See you in the next video and bye.